All right, we're back. So let's talk about logarithmic functions. Excuse me. Let's say I give you this function, y equals to 2 to the power of x, and I want to find its inverse. So what do? I switch x and y like we talked about in the last video, and I'm going to solve for y. How do I solve for y? I can't. It's impossible. I can't divide by 2. I can't take the y root of both sides or anything like that. So a number of centuries ago, when scientists and mathematicians encountered such problems, they invented a new function called logarithmic function. And I think if you pronounce it in French, it's logarithme, so you can impress your friends at the next party before they kick you out. Logarithme. But anyways, so what's the definition of a logarithmic function? If I have a exponential function like this, its inverse is a logarithmic function. So logarithmic and exponential functions are inverses of each other. So I can write it like this. log, which stands for logarithms, and it has a base, and whatever this base is the base, and we always write the base lower than the log of y equals to x. And this is reversible. It goes in both directions. So if I have an exponential function, I can write it in logarithmic function like that. Let me give you a couple of examples. Let's say I have 9 equals to 3 squared. That's an exponential function, right? I want to write it in logarithmic function. So I'm going to write log, what's the base? Base is 3 of 9 equals to 2. Now, how do you check whether you wrote it correctly in logarithmic form? Well, if you take the base and raise it to whatever is on the other side of the equal sign, and if that equals to this number, then you wrote it correctly. What's 3 to the second power? 9. And that's what we had. So I wrote it correctly. Okay, so that's how you can check. Let's try one more. What if I have 4 squared equals 16? That's an exponential form. So I can write it as log, what's my base? 4 of 16 equals to 2. How do I check it? The base to the power of whatever is on the other side of the equal sign equals to this. So 4 squared is 16. So I wrote it correctly. Okay, if you wrote log base 4 of 2 equals 16, then obviously you have a boo-boo, because 4 to the power of 16 is not 2. So you can always double check your work. What if I give you this? X cubed equals to 27. What's my base? X. So log base x of 27 equals to 3. And if I want to check it, x to the power of 3 equals to 27. And that's what I had originally. So I wrote these exponential forms, functions in logarithmic form. I can also do the other way. What if I give you this? Log base 10 of 1 equals to 0. Can I write it in exponential form? So what's my base? 10. Raise it to whatever is on the other side of the equal sign. So 10 to the power of 0 equals to 1. Is that a true statement? 10 to the power of 0, does it equal to 1? Yes, it does. So that's correct. What if I give you this? Log base 4 of 64 equals to 3. I want to write it in exponential form. Take the base, raise it to the power of whatever is on the other side. It should equal to this. So 4 to the third equals 64. Is that a true statement? Yes, it is. 4 to the third is 4 times 4 times 4, which gives you 64. So these are some examples of writing exponential in logarithmic or logarithmic in exponential. Okay. Now, we have 2 types of logarithms. We have 2 types of logarithms. We have what we call common log or common logarithm. That is log base 10. And usually in mathematics, if the base of your logarithm is 10, we don't show the base. Any other base has to be shown. Now, there's nothing wrong with showing it. You can show it, but usually we don't show it. So if I say, let's say log of 5, if the base is not shown, then it's automatically 10. Now, in all of your what do you call it, scientific calculators, the log key is the common log. The log key is the common log. So let's say I want to evaluate log of 5, so I just log of 5, and there you go. It's 0.699. So that's the value of log of 5. In the old times, like 40, 50 years ago, there were log tables when we didn't have scientific calculators. There were log, not that I knew any of those. I wasn't old enough to remember, but I've read, that you had log tables and people would look up what is log of 5. So you would find 0.699. But fortunately, we have the technology now. We don't have to use those charts. Another type of logarithms is what we call natural log. Not artificial, it's all organic. You see, I told you I'm going to have more jokes. Natural log. And what does that mean? Well, first of all, there is a symbol for natural log. It's ln. I don't know where it comes from. It's definitely not English. But what does it mean by natural log? Natural log means log base e. Remember we were talking about the natural base number, e, 2.71, that goes on forever. If the base of your logarithm is e, then we call it natural log because of the natural base number. And we have a special symbol for it, ln. So for example, if I say what is ln of 5, natural log of 5, and that's already in your scientific calculators, you see? It doesn't have to be a graphing calculator. All scientific calculators have log and natural log. See, ln. So if I say natural log of 5, and that is 1.609. So make sure you remember those, natural log and common log. So if log base 10, it's called common log. If it's log base e, it's called natural log, which has its own symbol. And log and the base, if it's 10, we don't show it. Okay. All right. Now, there are several properties of logarithms that I would like to share with you. If you go to page 464. Right. Oh, no. I'm gonna knock my camera off. So page 464, fundamental properties of logarithm. You see, for example, this one, if these two are the same, if the base and that quantity is the same, then the answer is always 1. Why? Because the power of that quantity is 1, so they cancel. Same thing with this one. If you have a 1 here, it's 0 because b to the power of 0 is 1. In more general sense, if the base is whatever the base is, if it's the same as the base of this, then everything cancels out. You get x, and if you have b to the power of that, it is x. Okay, and then we have. Let me give you a couple of one or two examples very quickly. So for example, if I give you log of 7 to the power of 3, the answer is 3 because these two are the same. Or if I give you 7 to the power of log of 7 of x, then the answer is x. This is a power, so if these guys are the same. So that was the example of those two rules. Okay. Then we have another set of three important properties of logarithm that's given to you on page 467. We have the product property. You see, if two quantities are being multiplied, you can expand them with an addition sign. So multiplication goes with addition. And you can reverse it as well. If you have two log quantities with the same base and you have a plus sign in the middle, you can condense it into one log quantity with a multiplication. Then we have what we call the quotient property. Quotient means division. If you have a division here, you can expand it with a subtraction. So division goes with subtraction, multiplication goes with addition. And that's also reversible. If you have two quantities with a minus sign, same base, you can condense it into one logarithm. And then the last one is called the power property. You see this P? That's a power. It can become a constant in the front, or not a constant, rather, a coefficient. It just moves to the front. Or if you have something like this, you can move the P and make it the power on that. Okay? So let me give you a couple of examples of properties of logarithms. So let's say, well, first of all, let's say I have something like this. 3 natural log, and it applies to natural log as well. Natural log of 2. I can write it as natural log of 2 to the power of 3 because this can go back up. And then, which is the same thing as natural log of 8 because 2 to the 3rd. And then if you want to evaluate it and so forth. Okay, so that's one example. Let me give you and one more, sorry, I forgot about this one, and one more property, which is on page 469. It's called change of base formula. Change of base formula. So sometimes if you need to change the base of your logarithm, you can use this formula. Now, what do I mean by that? So a lot of times we don't, let's say you don't have a calculator, okay? Because if the base of your logarithm is anything other than 10 or e, you can't use your calculator unless your calculator has one of these features that you can actually put the specific base of the logarithm. So, higher model scientific calculators like the graphing calculators, a TI-89 I think has those, but mine doesn't. For example, mine is TI-83. I think TI-84 has them as well. Okay, now let's say you have log base 3 of 5. And you want to evaluate that. You can change the base to log of 5 over log of 3. What did we do? What's the base now? If it's not showing, it's automatically 10. You see the bases are 10. Now, can I evaluate this on my calculator? Yes, I can, because I have common log on my calculator. So I'm following this. It also applies to natural log. You can, let me show you this one first. You see this log base b of m. This is on page 469. You can write as log of m over log of b. That's base 10. Or you can use base e. That means you can use natural log. Log base b of m, natural log of m over natural log of b. So the base goes to the basement. Ha! Base goes to the basement. Hoo-hoo. Or you can change it to any other base if you like. If you want to torture yourself. So if this is log b, base b of m, you can write log base a of b and log base b, a of b. All right. So going back to this, I made a change to common log. So I can say log of 5, make sure you close the parentheses, divided by log of 3. Did you have 3? Yes. And that will give me 1.465. So the value for log base 3 of 5 is 1.465. Let's try natural log of 5 over natural log of 3. Do we get the same answer? Well, let's see. Natural log of 5 divided by natural log of 3. Yowza, we got the same answer. So you can do it this way or this way. Either one gives you the same answer. Okay, so that's called the change of base formula. All right, so let's go to page 471. Page 471. And let's try a couple of problems here. Let's try number 25. So problem 25 is this. you have log base 2 of 7 plus log base 2 of 6. It says write the properties of logarithm, use the properties of logarithm to write each expression as a single term. Okay, are the bases the same? Yes. Do you have a plus sign? Yes. So I can condense it into one logarithm with the same base, but now what do I do with these numbers? I multiply them. So that gives me this, log base 2 of 42. So I wrote it as a single logarithm. I use the reverse of the product property that we talked about. I believe it was on page 467. Okay, let's try number 27. 27 uses natural logarithm, so you have natural log of 2x plus natural log of x minus 7. Okay, are the bases the same? Yes, because they're natural log, that means the base is e, so they're the same. You have a plus sign, yes, so you can condense it into a single logarithm. So natural log of 2x times x minus 7. And you can distribute the 2x if you like. You can get 2x squared minus 14x. So that will be the single logarithm, single term logarithm. Okay? And let me do one more. Number 37. Number 37 is natural log of x squared minus 4 minus the natural log of x plus 2. Okay, so again, do they have the same base? Yes, they're both natural log. I can condense it, have a minus sign, so that becomes the reverse of the quotient property, so that will be x squared minus 4 over x plus 2. I write it as a quotient, a fraction. Can I simplify that? Yes, because that's a difference of 2 squares, so I can write it as x plus 2, x minus 2 over x plus 2. And cancels, so natural log of x minus 2. So that simplifies to that one. Okay. I'll give you one more example of these. Let's say I have a log base 3 of x 7x. Let's call it 7x. Okay, so I can expand this to log base 3 of 7 plus log base 3 of x. Notice that they have, I expanded it. I had a multiplication here, so I expanded it. Okay, all right. I need to stop right here, and we will pick up in the next video, which will be very short.